Nu știu dacă s-ar putea să-mi puneți păr un pic cu AI, că nu-mi place poza prea mult. Wow. Deci, deci mă numesc Andras Ferenczi, prezentarea s-a făcut. O să vorbesc în limba engleză, dacă nu vă supărați. So I'm a proud alumnus of UPT. I've been in the US for like over 30 years. For the past 7 or so years, I've been I've been driving as a principal engineer, vice president, the research and development department of American Express. But I also have to tell you that a disclaimer that I'm here in a personal visit, so I do not represent American Express. These are my own views, so please don't quote me as talking on behalf of American Express. So that being said. So I see a lot of friends, sorry. So let's get started. So yes, my focus primarily has been for the longest time in distributed ledgers for about 5 years, intelligent automation, digital payments. I did some stint in health tech as well. As of recently, I've been drawn into this generative AI wave, which is just taking us by surprise. But I also spent a little time in researching quantum computers, and time permitting, I'm going to talk a little bit about it because I am personally very, very excited about it. So, the first thing I wanted to talk about is generative AI, because generative AI is probably the hottest thing that exists today. It's not the last thing, as I'm going to present. So I'm going to go over a brief history of generative AI as a good intro for this session. In around 2013, 14, variational autoencoders and GANs, generative adversarial networks, were invented. There were some publications and papers, and these networks were creating basically miracles because you would pit together two networks with GANs, and they would just generate for you some amazing pictures, right? Same thing with variational encoders, which took a little bit of a probabilistic approach to generating images. Then in 2017, the Vaswani famous paper, Attention is All You Need, came out, and it was talking about the new architecture, transformers in natural language processing, which really was able to create long-range dependencies between words in a sentence, and it truly revolutionized. I remember at the time when I was using BERT, for instance, which was one of the models that was created with it. Next came large language models, so neural networks, MLP, right, where you would have billions and billions of neurons that would be used. And obviously, they were using still the transformers, multiple attention heads to generate amazing responses, natural language responses. And this is something you guys know about ChatGPT and Anthropic and who knows, like Palm, Google's Palms, and all the other ones, right? Albeit, these are black box, so we don't really know the mechanism, but it's some kind of an attention mechanism they are using, definitely. Then came the diffusion models. The diffusion models, they would learn to reverse a gradual noising of an image. So they were, and with that, teaching the model, you would be able to generate some amazing pictures, and they were highly configurable. And then came the multimodal, and we are in this era, roughly, right? So we have where you are combining large language models with diffusion models, and you get something like stable diffusion, if anyone is familiar with it. I don't know if Sora is, we probably don't know how that was implemented. And the next thing is the next generation of models. And we are talking about Griffin here, Mamba, the KLN networks. There are alternatives. I'm not going to get into those, but there are alternatives to transformers, and this is all exciting because they bring a lot more. They become much faster. They are more accurate, and so on and so forth. There is another alternative future that is exciting me a lot. This is based on an idea of Ian Lee Khan, who is a chief scientist at Meta, where he's conceiving a different kind of architecture, which is very much agentic, by the way, agentic architecture, and he's coming up with this concept of world models, hierarchical world models, where the architecture of those are based on JIPA, joint embedding, predictive architecture, it's very interesting. With language models, you have text completions, so they are looking at pattern completions. So that is implemented using abstract embeddings. SSL, which is self-supervised learning, which means the model itself is capable of getting the raw data and generating supervisory signals that will help train the model. And what else? It is capable of prediction and planning as well. So these are all very, very exciting future. I don't know if this is what's going to happen, but okay. So I'm back to the area. This is the business where I'm working mostly. And as you see, we are using AI in just about everywhere. I'm not going to talk about all of them. I'm probably going to talk about the customer service and engagement part where I'm involved heavily. Chatbots, they are just amazing, and they are multimodal, and you can do whatever you want with them. We have sentiment analysis. Obviously, it's nothing new. But it becomes a lot better, and it is real time, and with generative AI, it is conceivable, like, for instance, where you have a customer service, you're talking to a customer service that can real time, it can sense whether you're happy or not. Personalized marketing, laser sharp targeting of customers with exactly what they need, and we have some amazing models for those. The customer feedback analysis, again, with generative AI, you can go to the feedback, and it's just going to summarize for you 1,000 messages, and it's going to tell you what's good, what's bad. It can give you reports if you want about that. Churn prediction is very important. If customers are dissatisfied, you do want to know why, and when you see that this is becoming a little intense, right? And my favorite is the intelligent user interfaces that we are designing right now, where we are used to dealing with menus and buttons and pop-ups and all that. I think in the next 5-10 years, that's going to completely change. You're going to have natural language communication with your app. In essence, I would say every application will become a chatbot. Now, the next one is the risk management security. This is very, very dear and near to us because I'm working in a business right now where we need to analyze the risks of every single transaction. And the models and the complexity of the models that you have to use is just amazing. But the problem with this is you are also facing regulators, so the models have to be accurate, but they also have to be explainable, interpretable. And that's where the balance, you have to be able to justify why someone got the credit, a loan, or why you had to decline a transaction, right? Credit risk assessment, both fraud risk and credit risk assessment are very good candidates, by the way, for the next gen, 5 or maybe 10 years from now, when we're talking about quantum computers. But if I'll have time, I'll talk about that as well. Know your customer and AML, KYC, AML, insurance underwriting, AI-enhanced cybersecurity. AI-enhanced cybersecurity existed for the longest time, but again, generative AI is adding a twist to it. It makes it even more interesting, even more exciting, and there are, I wish I could tell about it, but I'm under NDA, but with generative AI, you can do more. You can monitor things that your models, your bespoke models, have not been prepared for. They are not trained for it. And that's where the benefit of generative AI is. And of course, incident response, crisis and management. You will use generative AI to get all the feedback, all the emails, all the logs, whatnot, and you just feed them in, and then it's going to tell you, it's going to give you a summary. It saves a lot of time. What did I miss here? No, okay. Regulatory compliance, regulation in financial industry and the health industry is very, very intense. So you can always use the help of a very good large language model that is going to tell you exactly what's new and what you should pay attention to, or better yet, what you're not doing correctly. The compliance and the monitoring alerts, you can add all these generative AI tools to monitor your communications, to detect when sensitive data is being accidentally transferred to the wrong place, or where you're disclosing secret information, but also can help with when you're using LLMs, for instance, like prompt injection kind of things. Trade surveillance. Trade surveillance is something I did 20 some odd years ago. Bespoke models, so we did that. Risk assessment and mitigation. Again, there are models for risk assessment. Compliance training is another very interesting area where you can create a RAG, if you guys know, retrieval augmented generation model, where you load all the documents into some data store, and then you will have, you will allow the trainee to actually ask questions rather than just going through a raw document. I've seen that being very successfully implemented. And in operational efficiency, I've seen generative AI being used in operations, in production support. We have, for instance, developers' productivity increased drastically by using these code assistants. Think GitHub Copilot. We do see, and the industry general view is that the developers' productivity will be increasing by a factor of 10%. I would argue it's a lot more than that. And not to mention the fact that the first completely autonomous developer, if anyone heard about Devon, is also available. So I'm looking forward to see what we can do with something like that. Yeah, with back office support, obviously we know that Word and all the other tools are right now enabled with large language models and predictive maintenance. That being said, I need to talk a little bit about the risks that we're facing and the regulatory framework. And because I have the perspective from the United States, I know that we are dealing with the NIST, which is the National Institute of Standards and Technology, and they created a framework, a voluntary framework, the regulatory risk assessment framework for AI. And it also highlights pretty much the risks, all the risks that we'll probably be talking about, like the algorithmic bias, which is not new. I mean, heard so much about it, privacy violations, where AI will use in an unauthorized way sensitive information, security vulnerabilities. It's like membership inference, for instance, is one of the techniques by which one can obtain information about people, training data manipulation, and other things that can cause unexpected behavior. There's a lack of transparency and explainability. There is no secret about the fact that the large language models are not truly explainable, right? And it can create social and economic harms, infringement of intellectual property, environmental harms, erosion of human agency. This is like in the sci-fi, AGI will take over the world. We don't control it anymore. And the geopolitical risk, because LLMs can be manipulated to say things that are untrue, and we all know how big a risk that can be. And this is the final piece, because I said that right now I started looking into and researching a little bit quantum computing. Quantum computing offers a lot of potentials, is not quite there yet. We keep saying it's going to be another 5-10 years, and I've heard that for the last 5-10 years, so it sounds like it's a 10-year rolling window. But I've heard very recently some very promising developments that came from some of the companies, I'm not going to give their names, about logical qubits that can be created with low overhead. And sooner or later, some of these algorithms are going to be possible. So most of our problems in the banking industry are optimization problems, like customer segmentation, right? And risk management ones, like we can see QML being used in the future. It can complement classical computing. It can create things that you cannot create with classical computing due to its parallelism, superpositions, entanglement, and all that cool stuff from quantum mechanics, right? And therefore, it should be able to solve problems much faster than classical computers. I'm thinking like the Grover algorithm, to give you an example, right? Or the Shor algorithm, which freaks everyone else out, by the way. And quantum simulations can give you super quickly, very good sample data, which can be used to further train, to tune existing classical models, for instance. By the way, most of these models are hybrid. They are all hybrid classical with quantum. So really, I see the future of quantum computing like something similar to a GPU, a plug-in to a classical computer. And the simulation, pattern recognition again, due to its parallelism. So anyway, future is bright, it's unknown, it's very excited. I am very, very happy to be in this business, and I want to continue it for the longest time. And I guess that would be it.